minutes. Hey, hi, good evening, everyone. Good evening, friends. Welcome back to our SQL sessions. So, it's our day 11, and today we are going to discuss functions, right? So, before we understand the topic, let us quickly recap what we have covered in the previous day. Then we'll start the class, right? So, in the last class, in the last session, we have understood the concept of joins. We have understood the concept of joins. Am I right? Yes. So, what is the purpose of using joins? Come on, use the chat, and I want everyone to respond here. Use the chat. What is the purpose of learning or using SQL joins? Why should someone use SQL joins? Joins help us to perform, we can combine the data. We can combine the data from two or more than two tables. Good. So we actually combine, we are going to combine the records, upon the type of specific type of join that we specify. We can combine the records between two tables or more than two tables. What are the different types of joins that we have in SQL? We have understood inner join, left, right, full, and cross. What does inner join returns us? What does inner join return us? What will be the output of inner join? Everyone, everyone has to respond. Don't sit idle. What will be the output of inner join? Only the matching rows, the common rows. But before we, apply join, we have a condition. What is the condition? Ensure that there is a matching column. Ensure that there should be a matching column between the tables. It might be two tables or more than two tables. On the n number of tables that you're working, you're going to work on joins. You have, you should have a matching column, and using this matching column, we are going to perform join. Inner join will return us the common records. What is the syntax? The syntax will be like select columns, whatever the columns that you want. You need to specify the columns and ensure that you also specify the table name. Table name dot column name, comma, table name dot column name. In this way, specify all the required columns. Then from table 1 or left table, then specify the join type, inner join, then right table, okay, or table 2 on the matching column. Table 1 dot matching column is equals to table 2 dot matching column. So this is the syntax. So what is going to change is only the type of join will change between one to the other. Then what does left join return us? What will be the output of left join? Left join will return us all the records from the left table plus the common rows. The rows which are common between the tables will be part of left join as well. So I should say entire left table. So if I say left table, I can also have the common part. Yes, good. Then right join, what will be the output for right join? What will be the output for right join? Same entire right table. So when I say right table, including the matching. Okay, so this is our Venn diagram. So left, right, table 1, table 2. So entire left table will be the output for left join, and entire right table will be the output for right join. Good. Full join, what will be the output for full join, friends? What will be the output for full join? Good. All the rows, you know, both left table and right table together. Whatever the rows that I have in left table and whatever the rows that I have in right table, will be part of the output for full join. And does MySQL accept full join? MySQL, will it accept full join or not? No. Not only MySQL, we also have SQLite. So even this RDBMS, both MySQL and SQLite, you know, does not accept full join. So how can we achieve the output of full join in MySQL? How did we do it? How did we achieve it? Using the concept of union. Am I right? Yes. Why did we go with union? Why not union all? Why not union all? But why only union? Good, good. Keep going. Why union? Why not union all? The reason is when you use union all, you'll get duplicates. Okay, so the common part will be repeated twice. So when you have union in the picture, when you use union operator instead of union all, the duplicates will not be written and you can get the required output. Good. And finally, cross join. What does cross join does? What does cross join does? It returns the Cartesian product. Does cross join require a matching column? Yes, good. It returns the Cartesian product between the tables. Does a cross join require a matching column to perform cross join? Not required. In order to perform cross join between the tables, matching column is not required. Why? You know, the syntax is, or not only the syntax, as you are going to perform a Cartesian product, what happens? If you have 5 records or A records A number of records in table 1 and B number of records in table B, okay, or table 2. So in the final output table you'll have A into B number of records, right? So this will be the number of records in your output for cross join. So in this cross join, matching column is not required. We are not joining the tables using the matching column. We'll just perform the operation A multiplied by B. That is nothing but each and every row of table 1 will be combined with each and every row of table 2. Okay, so you'll get probably AB, some product. So AB number of rows will be the output for cross join. Clear? So any questions in joins topic? SQL joins. I assume no questions because the way that we have went, it's really good, and moreover, you guys have kept on interacting with me, so the session was very beautiful, right? So I assume no questions. Good. Now, so today we are going to understand a new topic, and the topic is window functions. One of the key topic in SQL. Okay, so in this SQL concepts, again, a fresher can be questioned from this topic. So focus. What exactly you mean by window functions? Or how does this window function help us as part of our queries? Everything we are going to look in today's class. What are the different types of window functions we have in SQL? Okay, we'll discuss. Window functions, they perform calculations across a set of rows related to the current row without collapsing them into a single result like aggregate functions. So what did you understand from the first line? Probably nothing. Yes. I'll just give an example. How many of you are aware of sum function? Or what does sum function does? I want you guys to respond. Don't sit idle. Okay. If you sit idle, we are going to learn nothing. At least yes, no, or type something that is relevant. How many of you are aware of sum function? What does sum function does? Sum function will return the overall aggregated value. If there are 5 records, and if I go with sum function, it adds up all the 5 values, 5 record values, and probably this will return me only some aggregated value, x or y value. Am I right? Yes, it sums up all the values. But these window functions, it does not collapse the original data. Okay, it does not collapse them into a single result. Whatever the records that we have will not be collapsed into a single result like aggregation functions. Then what does it does? It is going to work on a set of records based on the function that you specify. It performs the action, and moreover, window functions are always used with over clause. They are used with over clause. There is a clause called over, and using this clause we define a window. What is a window? Everything will understand. Okay, so this is nothing but a subset of rows on which we are going to operate the function. Okay, so we used sum function, right? As an aggregate function we used it, but if you use sum function as an aggregate, result is only a single value. If you have the values like this. And if I apply sum function, probably I'll get 15 as the output. Yes. 1 plus 2 plus 3 plus 4 plus 5, 15. But use the same sum function as an aggregate window function, as a window function using the over class. This is going to create or define a window. So majority of us will not understand the definition of window function here. If I go and explain with an example, you'll catch the exact definition of a window function. Right? So using a window function, you cannot expect only a single value like aggregate functions. No, this is for aggregation functions. But window function will result as the output for each and every row. Okay, for each and every row you'll have the output, but it depends on the function that you use using the over class. What are the different types of window functions that we have in SQL? We have aggregate window functions, we have ranking window functions, we have value window functions, and so on. But these are generally widely used. Sum, average, max, min, count are nothing but the aggregate functions. They are also part of aggregate window functions. The reason is I use all these functions using along with this over class. I'll have the combination of sum and over class, average and over class, max over class. So the syntax will be like this, friends. If you see here, the syntax of window function will be like this. Select the columns that you want to have, specify all the columns. It might be 2 columns, n number of columns upon your requirement. Then whatever the window function that you are using, specify the window function. On which column you are going to use, specify it. For example, let us go with sum of some xyz column. Then next to that we'll have over class. Within the over class we'll have the partition by which column has to be done. If you would also want to order that specific column, order by any column, you can specify order by class. Then I'm giving an alias name to this entire column. As a new column, I'm going to give an alias name. Then from which table you are supposed to mention the table name. So together this is the syntax of a window function. Okay, so the syntax will be same. Probably you'll be changing the column names, the window function. Okay, then the columns, depending on the table and the columns, the fields will be changing the syntax. But this syntax of window function will be constant. You'll not change it. Okay, so better we'll take an example and understand. If you understand one window function properly, okay, if I give an example for probably some window function, okay, then you can get a clear picture how these window functions work. So before that, I'll again once again talk about the types. Under aggregate window functions, we have sum, average, min, max, and count. Then next to aggregate window functions, we have ranking window functions, which helps us to rank the records, row number, rank, dense rank, entile, and finally value window functions, lead, lag, first value, last value, then nth value, different functions. And friends, there are n number of window functions. Out of them I have I have identified the best widely used window functions. Majoritarily, these window functions will be used more. So that is the reason, let us understand all of them in today's session. But some kind of attention is required because we are learning these window functions for the first time, right? So probably some kind of attention. If you understand one window function, the rest of them will be very simple. The same syntax will be used. Probably for 1, 2, the syntax will change, but the same syntax will be used. The function will change. From case to case, the function will change, right? So with no further delay, let us start our use case. What am I doing? Don't sit idle. What am I doing? I'm going to create a database. And what is the name of the database? The name of the database is company DB. Let's execute it. We got a successful message. So database company DB has to be, created. Again, don't get confused. Akhil, you have created company DB database in which you have uppercase and lowercase characters, but under schemas, I see only lowercase. That's what I have told earlier. SQL is not case sensitive, and moreover, when you try to create again one more database which is in full uppercase, it will throw you error. The reason is you already have it. Okay, so don't forget that particular point. SQL is not case sensitive. But when I was teaching Python, Python being a programming language, it's case sensitive. Is SQL a programming language? No, it's a query language. There is a lot of difference. Right? Then, after creating the database, let us go and use it. So, use database is the syntax. Use database name. Okay. So, you see that particular database has been highlighted under the schemas. So that means we are using that database. Then create a table. Okay, I'm creating a table. What are the columns? What is the name of the table? The name of the table is employees. Okay, what are the columns? The columns are employee ID, name, department, salary, joining date. So the basic details of the employees. But if you see, did I come up with any constraints? Yes, there is a constraint. It is primary key. What does primary key tell us? What do you mean by primary key, friends? What do you mean by primary key? Good. No null value is allowed. Then what else? Only null value uniquely identifies a column. Friends, primary key is a combination of not null and unique. So no null value is allowed and all values should be unique. Good. So we have only primary key as the constraint. We also have auto increment. This auto increment is also a constraint which ensures that you know the values of this particular column will be incremented with by default 1. So I need not specify the values for employee ID, friends. Okay, so by default increment will be done when you try to insert the records. Okay, when you try to insert an employee details, you need not specify any value for employee ID. By default it starts with 1, and upon the insertion, okay, one record to the another record, it keeps on incrementing. Okay, so let me start inserting the records. You see, I'm trying to insert the records, but am I passing any value for employee ID? No. I'm inserting the records using insert command, DML command. Okay, so do you find any employee ID values as part of this query? No. Why? Because we have auto increment. Auto increment ensures that even though if you don't pass any value, by default it starts with 1, and it keeps on incrementing to the next record plus 1, to the next record plus 1. So it keeps on incrementing plus 1 value to the next record. So let us execute. An issue. Oh, sorry. I did not create it. Let us go and create first. Done. Now let me go and execute this insert command. Done. So we should have a table employees, and let us see visualize the data. So I can fetch the data using the select command. So this is my data. Okay, this is my data. Did I pass any values for employee ID? No. But why do you see the values under employee ID? Because of auto increment. Just because of auto increment, you can see the values under employee ID. By default, it starts 1, then the next value will have 1 plus 1, then so on. Okay, even when you try to insert few more records, you need not pass any value for employee ID. Okay, until unless if you want to pass anything, yes, you can do it. But this is our data, friends. Right. Now, let us understand the first aggregate window function. It is sum. Okay, so I can generally use sum function as an aggregate function. I can use sum, but that returns me only a single value. But window functions will not result as a single value. Okay, whatever we are going to learn as part of see, if you want to start with a different number, a good question. Anyways, see, for example, instead of starting with 1, okay, say if you want to start with some other number, by default it starts with 1. If you want to start with any other number, you are supposed to use alter command. We have alter, right? We can change. Use alter and change. See, the structure and all, you can go and use alter. So you can change the value, default values. If you want to stick with that basic, you can proceed. I hope your question has answered. Yes. So let us go and understand what does the sum window function does. Here we have the syntax. No, what are we trying to do? Let us understand. Probably should I reduce the size? Right. So let us map with the syntax. Select the column names, whatever you want to specify all the column names. I want employee ID, I want name of the employee, I want the department to which the employee belongs to, and I also want the salary of the employee. Only these 4 columns? No. I also want one more column. See, if I want only 4 columns, why would I mention this comma? So there is fifth column. What is the fifth column? The fifth column says sum of salary. I'm using the function. Focus, friends. I'm using the window function. It is sum of salary. So that means the values in the salary column will be summed up. But there is a clause here. There is a condition here. What is the condition says? Over partition by department. Don't aggregate all these values. Don't sum up all the values. There is a condition. Partition them based on department column. Based on department column, separate them, partition them. So IT is a department, HR is a department, finance is a department. Totally, we have 3 departments. Once after, partitioning them, then you go and sum up the values. Okay, sum the values of salary once after completing this action. What action? Once after separating department column, perform this action of and give an alias name to the column. What is the alias name? The column name is total department salary. Okay. And finally, the syntax should be completed right from the table name. So in total, you should get 5 columns, friends, not 4. 5. 1, 2, 3, 4, and 5. 5 columns, and this is my syntax of select. General syntax of select is select star from table name. But instead of star, I have come up with my column names. Okay, so let us see, let us execute all of these together. Is it right or wrong? Let us go and check. What is the first department? Again, if you observe carefully, all the values, the records, are they partitioned based on department? Yes, they are partitioned. The first partition, the second partition, the third partition. So it is creating the windows, window 1, window 2, window 3. Okay, since I'm working on a small data set, we can understand very quickly and clearly, right? So our understanding will be very fast. So I have initially partitioned based on department. Then what is the next step? The values in that particular department has to be aggregated. Go and check 75 plus 75. It's 150. 150 plus 60. So 210. Is it 210? Yes. For finance department people, we are paying this salary. I mean, if I'm an CEO, or if I belong to any management level person, I can get all the details that how much can we can achieve using this part. Okay, for X department, what is the salary that we are paying? For HR department, we are paying 105,000. IT department 215,000. I hope it's making sense. It's very simple. Instead of just some function, we are using it on a clause that is over. Okay, and here we are specifying condition. What is a condition? You are supposed to partition the data based on department column. So partition, and if you observe, all the departments are also arranged alphabetically. E, F, G, H, I, J. So F, H, I, alphabetical order, right? So they are partitioned 3 windows. Again, upon salary, the aggregation has been done. Hope no questions, because it's very simple and very clear. Now, will you do the same for average? What will be the logic for average? Use the chart and tell me what will happen. What is the difference between the previous query and this query? Very simple. Instead of sum, I have replaced it with average function. Any other difference? No. The number of columns I would like to have in the output is same. 5 columns, 5 columns. But this is using sum function. The previous case we used sum function, and in this case we are going to use average function. So what will be the logic, friends? Type it. Average of salary will be calculated, but for all the overall values, we'll take all the salaries of the employees present. That is not the logic. The logic says here. Clause. See, whenever you are using a over clause, it ensures that you are using window functions. Window functions are just used with over clause. So what it says that partition by department. Again, the same condition. The logic is same. So instead of summing up the values, it is calculating the average salary per department. It should be average salary per department. So for finance department, on an average, we are spending 70,000. HR 52,500. IT 71,666. Making sense? Okay, why it is same across all these last three folks? Because those 3 folks belong to the same department. So the average will be same. Okay, these three values are taken in the picture, and for these three values, the average is calculated, and it is 71,666. Right? Confusion. Good. In the same way, the maximum salary, this time I'll not explain because you have to be the answer. Give me the answer. What exactly is happening here in this particular query? What is happening in this query? What it is going to return us? Name, department, salary. But what is the fifth column? Chart. Use chart. Good. The maximum salary from each and every department will be returned. Okay, it's not finding maximum salary, because see, if you keep your statement, your answer as finding maximum salary, that means you are taking all the departments in the picture. No, for each and every department, what is the maximum salary will be the output. Yes, so answer should be clear. Salary it is 75,000. So for all the records of finance, it will be 75. For HR, it is 55. So 55 in the fifth column. For IT, it is 80. So in the fifth column, you'll have 80. Good. Then, in the same way, can I also calculate the minimum? Yes. Only thing that we have to change is instead of max, I'll go and use min. Instead of max, I'll go and use minimum function. So this will give me the minimum salary. See, in the previous case, we got 75,000 for finance. Now it is 60,000. So it's mirror image of minimum, maximum. Yes, that's it. Good. So far it is very easy for us. We are able to understand the query, and we were able to predict the output. But the next question that you are supposed to answer is this one. What exactly is happening in this query? What is happening in this query, friends? It is going to result as the employee ID, name, department of the employee, salary of the employee. But additionally, what we are going to get? Good. It is also counting the total number of employees in each and every department. How? I'm using count function. So this count function will ensure, or it will generally return the count of what? So count star will count the number of rows, right? So all the rows based on, so under each and every department, how many employees do we have will be the answer for the fifth column. So for finance, it is 3. For HR, it is 2. For IT, it is 3. Understood? I just use the logic of, window functions, that is aggregate window functions. I'm able to also calculate the number of employees and every, department. This is a very important question in interviews. They'll ask you a right query to count the number of employees or to return the number of employees in each and every department. So that time you need not keep all this stuff. This is not required. They want only the count, right? So your answer should be like this. Partition by department, because we are going to, get the count. Then from employees. If you are able to give an alias name, that's okay. If not, it's up to you. Alias name is generally, why do we give alias name is, you know, in order to understand the output properly, we give an alias name to our column. Clear? Perfect. Now, let us go and understand the ranking window functions. So these ranking window functions will, assign a rank for each and every row. See, so these ranking functions are used to assign a rank or to each row within the partition of a set. So as we are partitioning the, you know table into different windows, this particular rank functions helps us to rank or number the rows which are present in each and every window. What are the commonly used ranking functions? We have row number and type. Okay, so we'll understand one by one each and every function. The first one, row number. Row number function does. This will generally assign a unique rows within the partition by one. The syntax, if you see, row number function followed by over class, you are supposed to specify the column name on which you are going to partition. From here onwards, order by comes into the picture. Let us understand row number with example. What is the difference? The function has changed, and moreover, I picture. So what happens is, first it partitions the department. It partitions the data, the table into different windows based on values. So probably into three windows. Why? Three departments. So we'll get three windows, one for HR, one for finance, one for IT. Then for each and every window, it orders the values. Okay, it is going to sort the data based on salary. Let me take HR first, or finance, whatever might be. So if you take one department, in this department, it is going to, okay, in descending order the data, and it gives a unique number every row. That will be done by row number. The column name will be row underscore num. So if you understand this logic, how this is actually performing step by step, there is no kind of confusion. But majority of the folks fail here. See, let me execute this. You see, order by salary. The values will be ordered by salary. First partition based on department, yes. Then ordered by salary in descending order, yes. You see, under each and every department, the values of salary will be ordered in descending order. Then a unique no row number is given. Clear? Done. Then next to row number, we have rank function. This rank function is going to assign a rank to each and every row within a partition of result set. So this is actually giving a row number, right? But rank function will give a rank. For every row, it is going to provide a rank. Okay, what if there is a tie between the rows? The rank will be shared. Both the rows will have the same rank and the next rank is skipped. So how it is going to perform? Example. If you see, I have changed, instead of row number, I have changed it to rank. Then I'm using over class. So this rank function will work on this class. But initially we should get the output from here. So initially it partitions based on department column. So into three windows. Then it orders the data. It sorts the data in each and every window based on salary column in descending order. Okay, so within the descending order, uh, from top to small, from big to small, the values of salary will be added. Then the rank function will give unique rank for each and every row. Okay, what if two employees get same salary? Then the rank will be shared. If tied, that means if two rows have the same value, they receive the same rank. And the next rank is skipped. No, Akhil, I'm not getting the exact point. I'm not understanding. Can we understand it by the example? Yes. Here is the output. What am I doing? I'm going to give a rank based on salary. Based on salary, I'm providing a rank to my employees in each and every department. So if you take finance department, we have three folks who are being paid 75,000, 75,000, and 60,000. Okay, since I have ordered them, sorted the values in descending order, okay, from big to small. So the first person obviously will have the first rank, but even the second employee is also being paid the same. So in this case, if both the employees have same salary, the rank will be shared. The rank will be same. And what about the next rank? The next rank will be skipped. That is what rank. The next rank is skipped. Do you department finance? No. Why there is no two? Because two folks have the same rank, so the next rank will be skipped. For example, there are three employees who get same 75,000. So this fourth employee, the rank will be 4. The first three will have 1, but the fourth employee will have 4, not 3. So depending on the number of persons, the number of employees who will get the same salary, the rank will be shared. But the next rank will be skipped for the next employee. You see here, but in case of HR, the first person is ranked 1 and the second highest salary person is ranked 2. Even in IT also, it is 1, 2, 3. Because why you see the sequential rank? There is no tie. Only in finance there is a tie. If there is a tie, the rank will be shared. If there is no tie, the rank will continue. That is what rank function does. Okay. We also have dense rank. The next concept, the next function, it is dense rank. What does this dense rank function does? It is similar to rank. It performs similar to rank function, but the next rank is not skipped for ties. Even though if there is a tie, the rank will not be skipped by dense function, but rank function it skips. That is the only difference. Okay, for better understanding, the same example, only instead of rank, I'm going to use dense rank. Instead of rank, I'm replacing with dense rank. So let me execute this. Did it skip? No. But in rank function, in the previous case, it is 113. But now it is 112. Why? Dense rank function will not skip the next rank in the sequence, whereas rank function will skip if there is a tie. Okay, so these are very important, friends, because even for intermediate working professionals, or your career, if you're a fresher, you can expect questions from window functions, rank, dense rank. What is the difference between rank and dense rank? Even I have heard my from my many of my students have told this. Okay, so the differences between rank and dense rank is very important question. Yes. Okay, rank function. If there is a tie, it shares the rank, but the next rank will be skipped for the next value in that specific order. The rank will be skipped, whereas dense rank it does not skip the rank. The rank will continue as is, right? Then next to that we also have n-tile. So this n-tile will divide this result into specified number of equal groups. So depending on number of the syntax is like this. Within entire function, you are supposed to pass a value. So based on this value, that particular column will be divided. So if you see here, I'm specifying 2. So based on this particular 2, the salary column will be divided and the records will be assigned. That's what entire does. So if you see, what am I doing? I'm using the same syntax time again, only the function, and probably there are a few changes with respect to the partition by class over class. Okay, and I'm changing the alias name. If you see time again, I'm changing the alias name. I'm giving a proper alias name for my column. So this is up to you. Whatever name, if you are interested, you can come up with your alias name. But let us understand this entire. So for each and every department, I'm sorting the values of salary in descending order, and I'm partitioning them into two categories and dividing them into two. So this will ensure, and it gives a unique number. See, if you see for finance, what are the values we have under salary? 75,000, 75,000, 60,000. So these values will be partitioned, will be divided into how many categories? Two. Based on these categories, the number will be provided. So probably 75,000 in one category and 60,000 in other category. So that is the reason you see 1, 1, 2. Even here also, if you see 80,000 and 70,000 in one and 65,000 in two. So based on the column that you specify, it is going to divide the values and provide that partition number. That's it, entire. And finally, we have value window functions. These value window functions are again, similar, but they have a meaning for each and there is a meaning for each and every value window functions. So they are used to access specific rows relevant to the current row. Okay, so under value window functions, we have lag, lead, first value, last value, and nth value. So if you understand the meaning of the function, you'll get a clear picture on the output. Lag function. This particular function retrieves the value of a specified column from the row that is being specified number of rows before the current row within the same window. For example, it is going to lag one step behind. Towards one step behind, it is going to lag the output. The syntax. Same, no changes, yes. But the function, on which column it should lag? It should lag on salaries. Salary column. So, it initially partitions the windows based on department column, then sorts the data, using salary column. And in which order? Since I did not specify any order, by default it goes with ascending order, right? It goes and sorts the data in ascending order, then it starts lagging. What exactly this lag does? Hold on. What's happening? One step, this is your salary column. Yes. So you can get the previous salary. One step lag, one step lag. So within the department, within a window, this is a window. Why this is a window? Because partition by window, partition by department column. So only the first three rows will be part of window 1. Next two rows will be part of window 2. Last three rows will be part of window 3. Right? So, you know, these first three rows, we have the salary values and all of them are sorted in ascending order. So since I have applied lag function on salary column, one step lag, then one step lag. But why did we get a null value for the first record? Because there is no previous record. There is no previous salary. That is the reason we get a null value. In the same way for HR. So obviously, for each and every department, in each and every department, the first record will have a null value. In the same way, we have lead function. So this is quite opposite to lag. You can get the next salary here. See, the syntax is same. I'm just changing the function only. Okay, if you observe, I'm just changing the function. So in the previous case, the first record in each and every window, that is department, we have null. But here, the last row will have null. So this is lead. 70,000, 80,000, and last row will have null. Lead, lag. Lag is one step behind and lead is one step forward. So in each and every department, that is in each and every window, the last row will have null for lead, and under lag, for each and every window, the first row will have null. So that is the difference. Right? Yes. Then what about first value? This first value will retrieve the first value in each and every window. Okay. So for example, if you see, what is the difference? No difference. Only the function got changed. For each and every department, it gets partitioned, then sorts the data in descending order based on salary column. After that, this particular first value will take only the first value from the salary. That is nothing but the highest salary. Obviously, because I'm sorting the data in descending order. So for each and every column, for each and every row, the first value will be returned. See. What is the highest salary in finance? 75,000. Then HR 55,000. IT 80,000. Okay, the first value will be the output. It is nothing but the highest salary in each and every department. We have achieved the same output using max. If you remember, we have achieved the same output for this table using max window function. If not, you can achieve using first value as well. Both are same. Same in the sense, the output is same. Within every window, the first value should be the output. That's what we have written the syntax, the query. Right. In the same way, we also have last value. So mirror image. So this will return the last value in each and every window set. See. Since I have ordered this in descending order, I'll get the highest salary. I'll order it in ascending order. I'll get the last value. It is nothing but the lowest salary. See. Making sense? The last value in each and every salary column. And finally, we have nth value. Like how we are able to get first value, last value, we can also get the nth value for each and every window using this nth value window function. Okay, so the nth value of a particular window set can be achieved using nth value window function. And here is an example where we can get the second highest salary for each and every window. But this is bit complicated. Focus, friends. You see, I'm selecting the same columns. So employee ID, name, department, salary. Then followed by nth column. I mean nth value. This is the function. Okay. On which column you are specifying? I want to do it on salary column and I want nth highest value. That is second highest salary in each and every department. Okay, that is anyhow not specified here, but this 2 represents the second highest salary. Then over the department is mentioned in the over clause. In the over clause, if you see partition by department, then order by salary. This is again same. We are partitioning, we are making the windows using the department column, then ordering them, sorting them using salary column in descending order. Okay. Additionally, we have something else. What is this? Rows between unbounded preceding and unbounded following. That means consider each and every row in each and every partition, in each and every window. In general, this particular rows between unbounded preceding and unbounded following is not the basic field. Okay, it is not the basic window. It is the current row only. So because of that, what happens is it does not consider all the rows present in each and every partition. Okay, for example, I'll go back. If you see here, probably finance, or let me take IT. I have 70,000 employee, 80,000 employee, and 65,000 employee. If I say second highest salary, what should be the output? 70,000. Okay, so initially it partitions based on department. So under IT, we'll have 3 records: record 1, record 3, and record 7. Out of these 3 folks, you know, what is the second highest salary? 70,000. So obviously second 70,000 should be given as output for the 5th column. That is second highest salary column, 70,000 should be given. But if you don't come up with this particular line, it does not consider all the records for each and every window. The reason is here it is not unbounded following. What is this unbounded preceding and unbounded following? Unbounded preceding is nothing but all rows before the current row. Okay, then unbounded following is nothing but all rows after the current row, following, preceding. Okay, so this is a bit confusion terms that you usually use. So when you try to use this particular line, when you include it as part of your query, then all these records will be considered and you'll get the second highest salary as part of this column for each and every department. For let me execute. See, for finance, obviously we have a tie, so it's returning as 75,000. Obviously here it will be 50,000 for HR, and here it will be 70 for IT. Okay, so that makes the difference, friends. Anyways, just go through the session again if you are unable to get the uh, clarity on how does this nth value function works. We understood lag, lead, first value, last value, and nth value, right? So in this way you can get any highest salary, within an table, employee table. Even in interviews, they can question you like this: what if I want fifth highest salary in each and every department? So what you'll do is you'll just replace this 2 with 5. That's it. Replace this 2 with 5. So what happens? This is going to calculate fifth highest salary in each and every department. Okay, so using window functions is different, using clauses is different. Okay, so understand the question properly before you give your answer. How is the interviewer expecting you to answer? Using clauses. So using clauses, I can directly achieve it using limit and offset. Am I right? If you remember the concept of limit offset, so if I keep it as limit 1 offset 4, so I can get the fifth highest salary. Am I right? So the syntax will be like this: select salary from employees, order by salary, descending. Okay, descending order. Then limit 1. So one salary is enough. That is fifth highest. So offset will be 4. Okay, even that can be achieved, but you cannot get the employee detail. You can get that employee details, you know but for each and every department, if the question is for each and every department, there is no other option. You have to go and use nth value function only. That is only the fifth highest person across all the employees. This is for each and every employee. I mean, each and every department. There is lot of difference. If you get me, I'll stop it here. But if you did not understand what I'm trying to say, I'll explain it one more time. So, what you want me to do? Should I repeat it one more time, or is it making sense? Come on, guys. Upon your answer, I'm waiting. Explain. Okay, good. See, the question generally the questions are of like this, friends. Write an SQL query to fetch the details of the employee who is paid or who is being paid the fifth highest. Fifth highest in the entire table. In the entire table means, what does it mean? All departments. Am I right? Yes. Out of all departments, see, in a table, in an employee table, obviously you'll have the employees from all the departments. So out of all these employees who work in different departments, you can get the fifth highest using clauses directly. You need not make it complicated. How? I'll keep like this: select probably salary from table name, employees, employee details, whatever it might be. Okay, then order by salary. Based on salary only, you are supposed to order by. Perform sorting. Then in which order? Descending. Okay, since I want only the fifth highest salary, that is enough. So I'll use limit. Limit is 1, but offset should be 4. So that the first four highest salaries, 1, 2, 3, 4, these 4 will be skipped, and limit 1. So the fifth one will be given as output for this query. This is the query for the fifth highest salary in the table. But what if the question is like this? I want the fifth highest salary of the employees for each and every department. In each and every department, if I want to fetch the fifth highest salary, then this should be your answer, where 2 will be replacing 5. I mean, 5 will be replacing 2. Is it clear now? Why this comes into the picture is, here I'm using partition by, I'm creating windows, right? Using this department column, I'm creating windows, and I'm ordering how, using descending order, and I can get the fifth highest salary for each and every department. I can get the fifth highest salary. So that is the difference. Yep, is clear. So I'm satisfied. I'll stop the session here. Anyhow, I don't think we wasted our time, because we had a very good session. Because, you know, we should be very clear whenever you're learning something. It's obvious. You should be clear. Okay, even when you are giving your interviews, you should be in the same pace. Understand the question properly, first of all. Understand the question properly, then respond. What exactly is an interviewer expecting us from us? Okay, right. So, anyways, we had a great session, an interactive session. Thank you so much, friends, for your wonderful feedback and the effort that you are putting in these sessions. And one sincere advice is, you are supposed to do hands-on as well. Practice these queries on daily basis, especially joins, window functions. These two are very, very important, and you can expect questions as part of these two topics, right? So that's all for the day. Probably, yes, you can. We are going to share the feedback link as well in a couple of minutes, and I request everyone to hit on the like button before you leave, and also share these amazing sessions to your friends, your connections, whomever it might be. Yes. So, the feedback link has been provided. Fill the feedback link. Form has to be. Yep. Thanks. Thanks a lot. Fill the feedback link. Yes. So tomorrow will be the last day, because we have one important topic, that is, tomorrow we are going to learn the integration part, how a database will be connected with Python will be understood tomorrow. So I want everyone to join those sessions, because tomorrow it will be very interesting, and it is a very important session. So without fail, I want everyone to join the session. Right. So that's all for the day. Have a great day, friends. Um, yep, I assume no questions. Right, I'm closing the session. Right, we'll meet in the next session. Until then, take care. Have a great day. Signing off. Bye.